Welcome everyone to Your Desk University, bringing you live learning with AEC tech experts directly to your desk. My name is Timon Hazell. I'm a senior technical designer at Walter P. Moore. Tonight I'll be your host as we continue this series with another AEC tech expert. Today we're learning from Ehsan, the developer of pyRevit, about how to create great documentation simply for your Python and C# projects. The tricks will be applicable across the board. Why is he the one to speak on this? Hold on, and I'll answer that for you in about 30 seconds. But now, thank you. Thank you to you. You guys have been so engaged and supportive of this community effort. You, our viewers, you've made Your Desk University a huge success. You've reposted and brought your peers. This initiative, which started as a movement to connect the AEC tech community, has become just that because of your involvement. Thank you. Thank you. In return, we continue to do our best to bring you engaging tutorials and conversations of issues relevant to you. Set your Tuesday and Thursday reminders for 7 p.m. Eastern Tuesdays and Thursdays. We have 6 scheduled and 3 tentative sessions from now through June 9th. Next week, joining us will be Dana DeFilippi as our host from Smith Group, hosting Eileen Fan from Walter P. Moore. She'll be presenting about the simplicity behind Walter P. Moore's interoperability tools and how a simple storage method allows for accessibility by non-programmers and rapid adaptation for the additional tools such as quantity tracking, change management, incorporation, model comparisons, and data visualization. And now to our speaker, Iran-Nejad. Hey,
Hey
Asan.
everyone. Hey.
It's such an honor to introduce you to Asan. This man has taken a tool that was on the sidelines for Revit development and had the attention of a couple people and developed an entire platform for developers these days. Not only is it very stable, but it also has a vast and growing array of pre-built tools. You know I'm talking about Revit Python Shell and pyRevit. pyRevit is a gift to our community, as is true with many of the experts. He is not a man of one trick, though. He currently works for Rhino McNeil on the Rhino Inside project. He is also one of our industry's top developers and loves pushing the bounds of what he brings to the community. He's provided great documentation for his tools in forms of websites, examples, videos, and training. When Asan started hearing about people getting laid off, he started one-on-one Python tutorials. And I think I saw them sell out in just a few minutes. Is that right? I think I saw it happen at night, and then the next morning they were like all gone.
Yeah.
As such, he did not ask me for this, but in the spirit of supporting our AEC tech experts, I'm going to
Timon, can you raise your audio?
Yeah. I'm going to post a link here to his Patreon, where I encourage you to support pyRevit if you have. Just start with $5 or $50. Asan, thank you for being with us. And before you get started, can you tell us a little bit about pyRevit and your motivation behind starting it?
Yeah, I guess it all started about 6 years ago when I started a job at a architecture firm, and that was the first company that started using Revit extensively on large projects. And I quickly, after a couple of months, realized that the Revit itself is not very extensible. It doesn't have the necessary tools for large projects. So I kind of needed to find a way to use the knowledge of the Python programming that I had inside the Revit environment to be able to automate a few things. I found the Revit Python shell project started by somebody else, and I used that to sort of like bootstrap the Python scripts that I had created and run them inside the Revit environment to be able to automate my tasks. But after like a month or two of working, and after having like more than 30 something scripts, I quickly realized this is not going to be a very efficient process. So I ended up writing a starter script that was the pyRevit version 1, basically, just one monolithic script that loaded all the other scripts into the Revit UI. And that's how the pyRevit project started. And quickly after that, I published it online for free because I always wanted to be able to share these tools freely with the community, because I thought that our industry is littered with lots and lots of companies and developers and whatnot that charge for a lot of like different add-ons and whatnot. So I wanted to sort of like, provide a balance to that, a counterbalance to that, and provide something that's, the basic tools that you could get for free. That's how pyRevit really came to be. And over its lifetime, it grew rapidly into a having a set of tools and being a Python development environment.
Yeah, I mean it's massive, and I know so many companies that are using it. So thanks for that. But today you're going to talk to us specifically about documentation. Is that right?
Yeah, yeah.
All
We're
right,
going to talk about why do we document, and I'm going to show you a few ways of how I'm documenting stuff, and I hope everybody finds it useful.
that sounds perfect. All right, let's get started. Thanks.
Okay. Okay, so I'm going to share my screen. Desktop 2.
And I don't think I mentioned this, but we really love the chat, guys. So if you have questions or whatnot, Asan's not seeing that live, but I'll be watching it and I'll be feeding him your questions as they come up. And if you like we've actually seen, it's kind of funny. We've seen love for Asan on other chats that we've seen. So +1 for you. Thank you so much again.
Hold on, guys.
And looks like
here.
that looks great. Yeah, the presentation's coming across. Perfect.
I figured it out. Okay. Okay, so the funny title for this presentation is Condemned to Care, or How I Learned to Stop Coding and Love the Ducks. In this conversation, I want to talk to you about the why do we really document things. I'm hoping that by showing you the importance of documentation, we would be creating more of an incentive for open source developers to add more documentation and wikis and guidelines and stuff to their projects. One of the most important things about open source is that it's different from everything else. And part of the reason that it's different is because you have created a set of tools that are going to be used by people from all walks of life. When you generally create a closed source software inside a company, the people that generally work on that project are kind of having the shared background. On an open source project, people come from all sorts of backgrounds. So what really happens is that there is the first person who is the creator of the project, and that person is the first user and the first developer. And then the project size is, formed around the use cases for that single person. But then the moment the first enthusiast as the second user finds your project starts kind of growing and it starts changing shape. This is also one of the most important aspects of the open source projects because it's hard to control what the shape of the project you want it to be because everybody has the source. And quickly, or in case of pyRevit, after many years, you have a series of users surrounding your product, getting feedback to you, reporting errors and all that kind of stuff. And you notice that the shape of your project has completely changed, and it's so much bigger than you initially thought it would be. And that causes panic. As a single developer sitting in the middle of this project, you kind of have to figure out a way to keep this project alive and update it so it stays relevant and it's supporting the users that it already has and the new users that are joining the project. There's a pretty good solution to this problem, and that is to start converting users to developers. The more users you can convert to developers, the more power you have in supporting your project and adding more features and whatnot, and supporting the users and bringing even more users into the project. So what we're going to talk about is that how do we convert a user to a developer? They are in this conversation. I've laid out a sort of like a set of 3 steps where it takes a user from one side to the developer from the other side. The first thing that generally users do when they see your project is that they want to do stuff with it. They want to use it for what they're using it for the tasks and whatnot. And then once they start using it and learn about it and kind of sort of like challenge themselves with it, they want to know how these things really work. So they want to start learning how these things work. And then after that, once they sort of like learn the general concepts and basically how the inner workings work, they want to actually see your code and see, okay, so how this mathematical function, how does it really work? And then they want to go and see that code. And that generally happens inside your code base. And at that point, you would assume that they already know the language, they've seen your code, they're familiar with the code and stuff. So they're potentially a developer. They're ready at that point to start giving back and contribute to your project. And here's when this huge master plan really comes into play. I apologize. This huge master plan really comes into play. If you take one thing from this conversation, I would like you to take a snapshot of this slide and just keep it on your references for your documentation. I've actually taken this from
So I
somebody
should
else that
print
I've seen
screen
on
this
the web.
right now. I'm going to print screen it myself, along with
Yeah, yeah.
everyone else.
I've actually taken this from somewhere else on the internet, but I've sort of like simplified it in a way that it sort of like makes sense for us. There are 4 segments in this chart. The 2 at the top are noted on the side, on the left side, and they're the practical steps. The 2 on the bottom are theoretical knowledge. And then the 2 on the left are studying, the 2 on the right are working, and they're noted at the bottom of the chart. This means that the 2 on the left are generally, we deal with them when we're studying and learning about that new software or tool or whatever platform is. The 2 on the right are the ones that we generally refer to when we're working with the tool. The first one, the top left one, is tutorials. It is learning oriented. You want to, that's generally the first entry point for a user that walks into your project. You want to teach them how this thing works very simply. Don't take too much of their time. Don't require a lot of like knowledge and sort of like experiences and stuff with other things. So you take their hand and you walk him through a few things that your application does, and you teach him that. And then you walk into the next one, the top right one, that's how-tos. Now you realize, you sort of like acknowledge that this user has a series of challenges that they like to solve. These how-tos are problem-oriented articles or videos or basically content that take the user through a very specific problem. For example, if you're a Revit user and want to set up your project with shared coordinates, setting up a project with shared coordinates is a how-to article. It takes you through that challenge, teaches you how to do it, does not need to expect you to learn or know everything else about Revit. And then you go to the guides. Guides is understanding oriented. The main purpose is here to teach the inner workings of how this application or how that feature works to the user. And the last one is the references. These are the ones that we have seen most of the times because generally they are the easiest to generate. Most of the generators for these kind of references are automated. They are basically what we normally refer to as API documentation. Like when you see API documentation for Revit, or if you use web services and web APIs, you can see a lot of these stuff on websites and whatnot. And I'll show you a couple of examples of those. And these are purely information oriented. All they want to do is that they want to transfer the information and the comments and the sort of like types about the code into a referable, easily referable document format that we can always access online without really needing to clone the repository and look into the code ourselves. So going back to the conversation that we had about the user and those 3 steps to become the developer. On the first step, we'll provide the tutorials and how-tos to them because they're the ones that are practical guides. They show the user how to do things. On the second step, when they want to learn more, we give them the guides and references. They are understanding oriented. They're basically theoretical articles. You give these to the user, guide them through things, how things work, and then you also give them references so they can easily refer to. At each one of these steps, the do stuff and the learn how, if you remember this chart, we have one from studying and one from working. So when they're doing stuff, they use the tutorials. When they're learning, they use the how-tos when they're working. So if they're in the work environment, they're working on their project, and they just forget how to solve a challenge, they can always refer to your how-tos. It's hard to go through anything else. How-tos makes it really easy. Same thing with the learn how. If you go when they're learning, you can read the guides at your basically pace, but you kind of need the references because when you're programming and when you're doing stuff, you kind of need that API reference really quickly to be able to access those. And then aside from these 4, we have one that is arguably the most important part, and we'll talk about this in a little bit more detail. That is the readable code. That happens when the user wants to see the actual code that you have in your project. It's incredibly important that you have readable code that's commented and it's easy to read for the user. Part of the reason that this is basically so important is that from the readable code, you could create references and guides and how-tos and tutorials. But from those 4, you cannot create a readable code. If you don't have a code that's readable, most of the users are going to stop at that node because they can't go further. because to understand a code that's not readable, you basically have to become an archaeologist. You kind of have to go through every line of the code, try to understand what it does, and then think of why it does that, and then sort of like try to understand what's going on. So that piece is arguably one of the most important pieces in the process. Now, going back to the master plan, the ones that I've sort of like circled out with the red lines are the ones that need the most care from you as a developer. They are the ones that I generally call curated content. You can't really generate these automatically. You kind of have to sit down and write a tutorial or make a video, write a how to make a video, and sort of like fine tune it based on the target audience that you have. Write the guides, make sure they're stay sort of like relevant and valid as your software changes. So the red area is the one that takes the most work. You kind of have to figure out for your project how much of these you have to generate. I would suggest have at least one of each these areas, but sort of like how deep you want to go inside the how-tos and tutorials and guides, that's kind of up to you and up to based on the sort of like the project that you're really working on. The last one is references, which I've circled out with the green lines, and that's normally generated automatically because all it does really is that it converts data from one format to another format for easy access for us. Now, let me take you through the Rhino Inside Revit wiki that we have created for the Rhino Inside project.
Oh, my Rhino Inside has really changed the way a lot of people are working. It seems like, it's not only helpful, but it seems also, I almost want to call it like a buzzword right now because everyone's like, oh my goodness, Rhino Inside, Rhino Inside. So we're really thankful to see all the stuff that's happening.
Thank you. Yeah,
if you agree, let us know in the comments or in the chat.
So let me actually make sure that I've got this right. Okay, so this is the homepage for the Rhino Inside Revit project. On the top, you see the project is listed. We'll talk about this beta at the end of it later. We have the getting started. That's the closest thing to the tutorials that we talked about. We have guides, samples, references, and the rest of the stuff that we'll talk about. The homepage for the project, all it has is basically has a video to get everybody excited about this project and basically explain very quickly what this project is. It doesn't act as a tutorial. It's basically a promo for the application. And the rest of the content on this page takes them through these tabs at the top and explains what each one of them are, so they can understand what's going on. There are download buttons provided here for easy access, so they can open the wiki and sort of like use these buttons always to download stuff. The first place that they go to, I'm going to go here, getting started. This is the tutorial. This is the closest thing that we have to the tutorial. It is basically one article, one long article that takes about like 10 minutes to read. It has a lot of images and code examples and stuff like that. These sections at the side are just hyperlinks to the same document, so the user doesn't navigate through multiple different pages at this point. It's just a single page. All it does is that it takes your hand as a user, goes through the installation, loading it, sort of like doing taking you through performing two of the most important tasks in this, which is bringing geometry from Rhino to Revit and Revit to Rhino. And it also takes you through creating your first Python component for the project as well. So like at the bottom of it, there's code examples and stuff like that. But everything is super, super simple. And all it does is that it wants to make the user comfortable with this environment. Getting it installed on the machine, getting it comfortable on how basically it works very simply. The second part, the guides, and the third part, the samples. You might think that they are sort of like the samples should come before the guides because samples are really how-tos. The reason that we have flipped these at this point is because the target software that we're dealing with, Revit, is massive in terms of its data modeling. So what I wanted to do is that I wanted to get the users into the understanding sort of like first when they walk into the website. We still have provided links to them. So if they want to go directly to how-tos or the samples on this wiki, they still can. But in terms of like the natural progression of going towards, and getting better at this software, I wanted them to take a look at the guides more and first because it's such an important aspect of dealing with Rhino Inside Revit and Revit. And then we got these guides are basically the closest thing that are Basically, it matches the guides on that chart that I showed you. So each one of them, like for example, data model, let's say data model types. This talks about how Revit's data model is organized. And there's nothing really here about the software itself. These are conceptual conversations and sort of like tutorials and stuff that, okay, so you can do this, you can do that. And the base goal is to try to help the user understand how really Revit works. So that's that. And then on top of that, we have samples, which is, again, I mentioned these are how-tos, and they're problem-oriented. So creating a building shell using adaptive components, analytical model manipulation, creating a wall in Revit, like from simple to hard ones. And these are by no means sorted or like created in sort of like in with a predetermined goal in mind. They're what we had from the content that Scott specifically generated while he was showing the software to other people and stuff before we actually had the wiki. So, and then this is the sort of like the Rhino Inside Revit wiki. And I want to show you pyRevit wiki at this point also. Now, pyRevit has the getting started. It basically explains what this is. This is sort of like the homepage of the Rhino Inside wiki. It basically tells the user what this project is and what it can do for you. And it will take you to a subsection which acts as a tutorial. But because pyRevit has two massive use cases, one for the users that just want to use pyRevit, and the other ones that want to use it to develop their own content. This is not improving and developing the pyRevit core. This is using pyRevit to develop your own tools. So you get a getting started article or a tutorial article for each one of these use cases. And then going deeper into the developer docs, this is sort of like the area that needed the most attention because pyRevit as a development platform is fairly complex and whatnot. So there are plenty of articles to get them started on different things and videos on how to teach them to sort of like, develop add-ons for Revit and whatnot, and a whole lots of other references that the users can use. Now, let me go back to the slides.
So you're using Notion as a backend for all of that.
Yeah.
What was your reasoning behind using Notion?
I'll get to it. Let me get to the documentations, and I'll talk about that in a little bit detail. Okay. Let me see. I was just checking how much time do I have. Okay. So one of the things, the first part that I want to talk about here, after I showed you these, is that we talked about the curated content in this demo that we had. We didn't talk about the API documentation and stuff. We talked about the tutorials, how-tos, and guides. Those are the ones that are curated. I highly suggest you using a format like Markdown, because Markdown is kind of declarative in its style. When you create a header, you basically declare that this is the level of the header that you want it to be. This is a header 1 or a subheader 2 or this kind of a content, or this is a link to an image or a link to a URL and stuff like that. And later on, because you describe the structure of this document that you're generating, later on, a separate process can take this and convert it to any sort of theme and style and whatnot that you imagine, depending on the theme that you have for your documentation website. So if you have the content in a declarative format like this, you can change the theme of your website without really affecting any of the content that you have generated for your wiki, which is incredibly important because it helps you keep this documentation updated and relevant as you go along. What we use generally in this process is they're called static site generators. They take the markdown. If you look at from the left side of the screen to the right, they take the markdown file that you have that we talked about. It goes through a process using that site generator, notably Jekyll or Hugo. By the way, if you are starting your documentation using sort of like any of these tools, go with Hugo. Jekyll is a little bit older. Hugo is much faster, has much better API and stuff like that. Unless you have to stay consistent with the platforms that you have at work, I would use Hugo. For the Rhino Inside Revit, I use Jekyll to basically stay consistent with what we had at McNeil. So basically, your markdown files go through a process, and Hugo or Jekyll generates HTML, CSS, JavaScript, or other formats if need be, like PDFs and Windows help files and stuff like that out of this. And then you can serve this static content. They're not dynamic anymore. They're basically converted from the markdown to this format, apply the styling and the interactivity using JavaScript. And then you can serve it on GitHub or Forestry or any other platform. You can spin up your own web server and serve this content on the web to your users. A good example of this is Rhino Inside Revit's Wiki. It's generated using Jekyll. All the documentation is in, all the content is in Markdown. It's all available on the GitHub repo, so you can easily go and take a look at it and stuff like that. And it's all generated into HTML, CSS, and JS and served on GitHub, and that's where you see them. For the pyRevit project, this is what I initially started doing, but because pyRevit was sort of like a side project for me, and my day job was something else, I couldn't really spend too much time on the infrastructure behind the documentation, and I wanted to have a way that I can easily update this documentation without basically being available from anywhere. What I chose is the Notion platform. Notion is an amazingly designed documentation. It's not really a documentation platform. It's like self-knowledge base, whatever, or like team wiki kind of thing. It's hard to define what it really is, but it's basically a WYSIWYG document editor on the web that you can add any sorts of document and code samples and stuff to it. You can use it within your company, closed inside your company as your wiki, or you can open it like this to the outside with a flick of a button. You can open it to the public and make those pages public and whatnot. And that's what I've really done. Behind the scenes, this is a Notion workspace with one page, which is the root of all the other pages in pyRevit, and that page is public that you can see on the everywhere. What this means is that if somebody makes a comment about something, that something is wrong in the documentation, I can literally open my phone when I'm sitting in a bus or in the car or whatever, and I can make some change and not worry about it anymore because it's already updated. So you kind of have to pick and choose the tool chain that you use to do the sort of like this document generation for you, depending on the use cases that you have, depending on how much support you have on this project and the kind of project that you have also. This is an example of the Markdown document that we talked about. If you look at the top of this list, this is generally a Markdown document that you use with a platform like Jekyll. On the top, you provide some metadata about this document, like what kind of a HTML layout should be used for this page. And then you can have liquid templating standards that are consistent between Hugo and Jekyll. So once you learn them, you can use them in both ways. The APIs are slightly different, but the general design is still the same. You could include snippets of HTML to include basically a YouTube player for a YouTube video that you have, download links, like those download links that I showed you on the Rhino Inside Wiki. That's basically the single line that brings both those buttons into the documentation. And there's a variable called version provided to them, so it provides the correct version of the download buttons into the wiki. So basically, this is how the source of that document looks like. And you see there's no styling. You basically just describe what kind of styling do you want to have. At this point, I wanted to show you the sort of like automatically generated content that we generally deal with. I lost my mouse. Okay. So this is the, yeah, okay. So again, going back to the Rhino and McNeil content, this is the documentation for Rhino Common, which is the general open API of the Rhino application. You can see that inside of this, you can access all the API object. I'm going to go to, let's say, Rhino geometry, and I'm going to open a box, and you can see the class methods and properties and all that kind of stuff with the descriptions in front of them and what kind of data it takes and returns and all that kind of stuff. This is the type of documentation that is generally automatically generated from your source code. Another example of this is the pyRevit documentation. pyRevit documentation is linked inside the wiki. So you go through the wiki, but you get here from inside the wiki. And what this does is that it documents the pyRevit source code. However much of it I've really documented, there's plenty that's missing in here just because I haven't really gone to documenting those. And that's something that I failed sort of like to do as I was developing pyRevit. And that's one of the reasons that I learned all these documentation best practices and stuff through pain. But basically, this is what it does. This is an example of it's a Python. Let's say, let's slide down.
So all of this, you're saying all of this, the examples, all the information is coming straight from the code.
Yeah, it's coming straight from the document, and I'll show you how it works basically. So you can see a Python class here, name of it, what it takes, an example of it, and whatnot, generated automatically and basically served automatically in this case also. For the C# stuff, you can use a platform that's called Sandcastle, and we'll talk about it. For the Python stuff, another platform is called Sphinx. Sphinx actually can generate, as far as I know, I've never actually used it to generate anything other than Python code, but apparently it can generate other documentation from other programming languages through extensions. So let's go back to the slides. Okay, so this is an example of a C# code, and you can see on top of it, there is a summary inside sort of like XML style tags, and then the return value is also listed here. This is the convention that Visual Studio uses to provide the description of what that function does, and sort of like the return value from that function. And you can use this to, and it will basically use this to generate the documentation. The static document generators, similar to the curated content generators or the static site generators, they'll take your source code. It goes through the process using Sphinx or Sandcastle that we mentioned, and it would spit out the HTML, CSS, JS, or other formats, maybe PDFs and whatnot, and you can serve it on the websites. In case of pyRevit, I'm using the Read the Docs website. Read the Docs website, when you actually make a change to the code, it automatically pulls your code, builds your documentation, and it also serves it in this format here. And it also provides like other methods of accessing it. You can download the HTML or PDF, and like a couple other things that you want to download. And you can also serve multiple versions of your documentation. So that's pretty cool. Sandcastle is also similar. Now, here is the most important part of this sort of like conversation about documentation. This is the part that we talked about as the readable code. Notice that inside this C# function, there's a to-do comment at the top that says, maybe this function could benefits from performance improvements. The beauty of this is that these to-do tags will show up in the IDE environment that the developers use. So maybe some other developer will see this later on, and they think of a better way in the way like how to improve this. And you can see the rest of the code has plenty of comments that basically describe what that code piece does and why it does do that. Or in the case of like this example, you can actually use ASCII art to draw charts and explain why that piece or how that piece is doing that calculation, because you think when somebody looks at this, it would be important for them to understand very easily how this thing works. Okay. So now your project, I'm going to go here again. Your project could also benefit from some interactive content. Like if you're creating your documentations and guides and stuff and including images, a GIF image like this tremendously helps conveying the concept that you're trying to convey. Don't resort to writing stuff all the time. Creating a GIF like this doesn't really take that much time. Set up the tool chains and the workflows to make yourself comfortable with this. And it basically exactly explains what I had to explain in like 10 lines as to like how this works. And even at that point, the user wouldn't really understand how this works until they can actually play with it. Or if your project kind of like allows, you can even provide interactive content inside your documentation that I can hear and come run the code, and I can also make changes to it and run it again, just right in the interface and see the changes. So this kind of content is actually very helpful also, depending on your project and if it allows for this kind of interactivity. There's a whole bunch of other stuff that the user wants when they come to your wiki or the documentation website. One of the most important ones is a roadmap. You kind of have to, depending on your best practices, you kind of have to provide a roadmap for the user. Like this is the roadmap for pyRevit. What is coming in next release, and what are the planned features by the release? So there's a list of backlogs, and this is 4.7.7 and 4.7.8. I haven't planned anything for that yet, but that's sort of like documented and shown to the user so they can plan to see these features. Make sure that your documentation website or the platform that you choose allows for different versions of the platform that you create, especially if this is sort of like an API that they need to use. Some users might want to stick to a specific version of your code that you have created for backwards compatibility. And that's part of the reason that you saw this beta version in here. The only version that we have is beta, but once we move to the first version, the whole documentation about the beta will still stay there. and we'll upgrade the rest of it. We'll basically make a clone of it and update it for the version 1. Make sure that you kind of provide a forum to the users so they can reach out to you and talk to you about these things and ask you questions and whatnot. This helps solidifies this knowledge into one platform, and it makes it referable to referable to everybody else. They can just copy links around and share solutions to problems. Make sure there's a troubleshooting website page on your wiki. It makes it very easy to direct the users on the type of standard problems that they have, that they can take a look at this and solve their issues and whatnot, like how to submit debug info for the Rhino Inside Revit project. Creating a page, an area to let the users how they can get involved with the project is also really important. For pyRevit, I wanted to ask the users for their passion, if they want to help me with the rest of the pyRevit stuff, or they want to share their code, or they want to share, support the project financially. So make that clear how these people can support your project. And
because not everyone's going to be a developer, right? So
yeah,
that
exactly.
provides a little bit of a different interest. One person might just like to create, documentation, little video snippets. Another person might, be better at like writing out documentation or whatever. That's interesting. We are getting a couple questions. I'm gonna let you keep going, and then we'll get to some of those.
Okay, and then also make sure that you give a shout out to the community, to the people that are part of your community, and they're doing anything for a project. Like these people have created videos for the Rhino Inside Revit project, and we have sort of like give them a shout out on the wiki as well. And it also shares the resources with everybody else. Hugo, we talked about, this is the website. You can use it. It's an amazing platform. It's super fast, and the API is also amazing. Read the docs. I mentioned this. Read the docs. The beauty of this is that all the documentation upgrades are automatic. It just pulls the content from your GitHub repository, regenerates the documentation, and serves it at the documentation link that you have. Now, at this point, the last part of the conversation that I want to have with you is this, that once we converted users to the developers, we kind of have to make sure that they also give back to this process that we basically created. They can generate readable code. They can generate references, these automatic APIs from documentations from those APIs, and they can also help generating tutorials and how-tos and guides. So what we do is that we want to make sure to give them code conventions so they understand readable code, how to create readable code. What are the conventions? What's your C# coding style, for example, for your project? Are you using Microsoft C# style or other formats? Just to make sure that your code base is consistent. And then code documenting conventions, explain to them that we are using a Sphinx. This is how it works. This is how you built our documentation and stuff. And then how to generate the guides and the content for your wiki. This is what I call the meta wiki. This is the wiki about the wiki. So the last slide is basically this, that on the Rhino Inside Revit project, the homepage for the project, the README explains what this project is. This is not part of the wiki. This is the meta project. This is where they come to the source code and they want to understand how the source code works. Or the, sorry, I keep losing my mouse on this screen. Or in this case, this is the documentation about Rhino Inside Wiki. There's this big document that describes how you create wiki. Sort of like, what is the online experience that we have designed for the users? It's all documented in here. Understanding the wiki source files, all that kind of stuff. Make sure that is also documented as well.
So that's now telling your developers how to create documentation of the pieces that they're doing so that it aligns with the project that you've created. Is that what you're kind of saying?
Yeah, a lot of times, like for example, if you at some point, if you want to have your documentation or wiki translated to a different language, you have to have this document so you can share it with a translator that is not necessarily a developer, but they want to go and set up these wiki pages in a different language, start translating, and make sure they follow the correct standards. And this is the last piece that we have for the Rhino Inside Revit. There's an art folder, and it sets up the standards for the logo, for the newsletters that we send out, and the icon design and all that kind of stuff. I actually have the icon design under the whip here that I forgot to pull. So we have like design guidelines for how you design icons for this project. And that's basically everything that I really wanted to talk about. So at this point, if you want to ask any questions and whatnot, I'm here. You can always reach me find me at ein.sh. That's my homepage. It has links to everything else that's related to me. And if you want to talk about the Rhino Inside Revit project, come to discourse.mcneil.com. That's the McNeil forums. And you can always tag me on any of the questions that you have.
Yeah, we do have a couple Rhino Inside questions, and I do want to say we don't have one scheduled yet, but our intent for one of those 3 open sessions still is to do a Rhino Inside workshop. Again, in the 20 to 30 minute range. There's other great videos and presentations that are out there. I just want to kind of do a shout out for that. But since you're here, I will throw at least one of these. Let's see, where was the Rhino Inside question?
Okay.
To get started with Rhino Inside, how much prior knowledge do you think people need to know of Rhino and Grasshopper? Can they start working on Rhino Inside and learn Grasshopper at the same time?
Yeah, absolutely. Grasshopper is a very easy program to pick up initially. So if you go to the, Jesus, this mouse is not really helping me. Okay. If you go to the, actually, let me open this. The developer documentations for McNeil. There are a lot of guides in here related to Grasshopper. There is a whole section on the homepage. If you go down on Grasshopper, that has a lots of really good articles, and they're not really long. It takes, like when I started learning Grasshopper, it probably took me like half a day to go through all of these. They're
Mm-hmm.
not really that complex. Some of them you don't really need to get started, like the Grasshopper icon conventions. You don't
Yeah.
really need those. So you can get started really quickly with Grasshopper. The critical concept to understand is the concept of data trees. So if you
Mm-hmm.
understand that, everything else after that should be fairly simple.
Mm-hmm. Yeah, and if people, we've specifically kind of shied away from 101 classes, but if people are not developers and they want to learn a little bit more about Grasshopper, there's also tons of videos and training for that
Yeah.
that exists. So we'll just kind of move on to a few of these. One was, is there a what you see is what you get, like a WYSIWYG type of editor for Markdown that you've seen or used?
Yeah, one of the examples. So if you go to Hugo, Hugo has a couple of suggestions on their website. Any of these, where is it? Oh, any of these will basically, Linode, I think it's just a Linux web server kind of mechanism. But the forestry is one of the examples of a having a sort of like a content management system for Hugo. And actually, you can edit your Markdown documents and stuff like that. It pushes the changes to your GitHub repo, and it builds that again and serves it, on the URL that you want it to be. So that's one of the good options. And I'm sure if you look up, there's plenty of other options as well.
So when you started, there's a question here about time spent as a developer between developing and documentation. I kind of want to rephrase this question in kind of 3 questions that you can answer. One is when you started developing pyRevit, how much time did you spend on developing and how much on documentation? Maybe a year ago, how much time did you spend? And then now in your current job, it sounds like at Rhino McNeil, you're doing a lot of documentation and some developing. Can you tell us like in those 3 timeframes what your like time how you spend your time?
So I guess pyRevit is not a very good example in that terms because I spent a lot of time writing code and rewriting pyRevit and stuff, and I really didn't document it as well as I should have. Most of the wiki that you see on pyRevit has been generated within a couple of months really quickly from the older content that I had. But generally, I would suggest for a developer, there's a lot of times that you have to spend with your team to figure out what kind of a feature you want and whatnot. But once you actually start sitting out and writing the code, I would spend equal amounts of time between writing code, the logic in your code, and commenting and documenting your code. We're just talking about code. We're just talking about the actual writing the logic and those sort of like documentation on the code and commenting that will be generated automatically to sort of like a reference documentation.
Okay.
And I would spend, generally what I do is that I spend twice this time that I spend for both of these creating other content, videos and tutorials and all that kind of stuff. Larger companies and larger teams might have different teams to do these things. And you kind of have to set up a really good communication channel so you can talk to those very easily to those people and convey the sort of like how software works and expectations and whatnot, so they can really write good articles. But documentation takes a lot of time.
Mm-hmm.
And that's why if you see like most of the softwares out there, they don't really have a large set of documentations just because it's hard to generate those. Most of the documentation that we see online and we refer to is API documentation. Most of the sort of like, especially big software companies rely on their resellers and the other companies to generate video tutorials and all that kind of stuff about their software and create a third party sort of like, support business, whatever. So you kind of have to decide which one of these is most appropriate for your project and the goal that you have. One of the things that I wanted to show you is that, like, for example, when I go through some changes in the code, I basically branch off, make my changes, test my changes, and then update the wiki in the same branch, and then merge it back to the source. So when I merge the changes back to the source, the documentation is already updated and it goes with it.
Yeah. So you talked about creating documentation for both users and developers. And then I know from past experience, you've created a lot of videos, which I know you spend a lot of time on, and then do presentations at, at conferences or things like this. How do you decide what area needs to be documented, right? Because we all have only so much time and we want to help
Yeah.
our users. How would you decide that if you were deciding whether to spend time on documentation for developers, documentation for users, or kind of training videos or images that go alongside that?
I would say that this is also the culture at McNeil. Also, the most important, you created this project and you shared it for as open source to the public because you cared about the users. So, following the same sort of like passion and concept, let this be a user-driven comment. So, generally, you have an idea of what your project is. You do the basic job at documenting stuff. Make sure most of the work that you do at this point is inside your code, because the rest of the documentation, as we mentioned, can be generated from the logic and comments and the documentation that you have inside your code. So make sure you're good on that part. And then for the rest of the stuff, you can start listening to users as the questions come in. Like, for example, I have a lot of users that come in and ask me, how does this pattern maker work? So I knew that I had to go and create a page dedicated to this, but just because there's so many questions around it. So let the users decide which aspects of your software you need to improve and which aspects of your documentation you need to improve.
Yeah. Okay. Well, if we don't have any, if we, I'm gonna ask another question, but I just want to tell the chat here that if you have any questions, this is like your last chance to get them answered. Otherwise, we'll probably wrap up with this one. But I do have to say, this is maybe more of a comment, but you can kind of feed off of that. Is so most of like my experience of learning pyRevit has come from seeing examples, and examples in the code have been really helpful. Do you have examples? Do you have examples of good examples that you've seen in other projects that you've taken that kind of that concept from, or providing that kind of feedback in the code, or maybe like in Grasshopper's examples, or like for people who are creating that type of documentation, which is like innate to the work they're doing?
To be honest with you, I don't have anything on top of my mind, but what I can show you, this is what I have that you, when we talk about the pyRevit documentation, you refer that the example is also documented inside the code. And this is one of the features that sort of like the Google style doc strings for Python will let you do, is that you can actually provide an example inside the same doc string, and the users will be able to see this on the documentation website the way it is. So if you go to the sort of like the pyRevit documentation, you will see that that kind of an example shows up here, nicely formatted as an example. So if you pick a platform like Sphinx or a really good document generator platform, you can do a lot of stuff in that documentation string that you have. You can add the examples, everything else. So you don't really leave your comfortable coding environment. You're still inside of that, and you add more and more stuff to here. Like for example, one of the things that I generally do is that I'm going to show you something from the Rhino Inside source code. Um, like I developed this script a while ago, and I basically go around and write this script and make sure it works and everything. As I'm writing the functions, I add the single line documentation so I can always refer back to and see what I've done. But once I'm done with the code and I've tested it and I know it works in different scenarios, I'll go back from top and start checking the documentation, reading the stuff that I have, adding comments, sort of like dividing different sections so that if somebody walks in, they can understand that this is the configuration for the tool and all that kind of stuff. So you always have to do it in multiple passes, just to make sure that you have documented and put enough information in there. And then the rest of it, you rely on your document generator to grab the content that you have and format it nicely on your results. And there's plenty of like all these tools give you a lot of flexibility in terms of like modifying the styling and like where things should be and all that kind of stuff.
Yeah. So, and Peter talked a little bit about the code generating part of this in the previous
Uh-huh.
session. But we do have a question here, because some of what you've talked about has really been a lot for external teams. You've talked about like pyRevit's engagement with the larger community. You've talked about Rhino Inside's engagement with the larger community. What about for someone who's developing mostly for an internal team or for their company's projects? Is it necessary to provide web-based documentation like this, or just internal traditional comments in the code? What are your thoughts on that?
So if you're dealing with a team of only programmers inside basically the same language, I would say. So like if your project is C# and all your team members are working in C#, you could rely on the sort of like the IDE that you're working with to provide those
The comments like directly in the
yeah,
code as you're
exactly.
going.
The tooltips and stuff for the documentation. As long as your code is documented, you don't have to generate anything externally. But let's say we're working part of a team that there's C# code, there's Python code, and there's interactivity between these stuff. You don't expect a Python programmer to go open a C# code to be able to see what a function works, how a function works. So you kind of have to provide some sort of a documentation to them. And I would argue that most of the developers are generally focused on a feature, and once they're done, they move on to another feature. And there's a very high chance that they would forget the inner workings of that feature that they have been working on. So having the documentation, at some point, they kind of become users of the code that they have previously written.
Mm-hmm.
So it's a really good practice to sort of like have this kind of level of documentation appropriately for the environment that you're working for at whether it's for public or for internal purposes.
Yeah, I would also add to that documentation for users internally, like a web platform, is obviously more accessible to that particular group that's not going to be diving into the code, and but that focuses more on use and how you use the project than how you contribute back to the project.
Yeah, and especially if you document stuff in code like this, or you use Markdown files, the eventual format of your documentation could always be modified by the generator. Mm-hmm. Like if you want a web page for your internal team, that's fine. If you decide you want to spread out like PDF files from your documentation, you can just generate PDF files from that file format, that initial source that you have. And that would be the source of your documentation.
Yeah. So with that, I think we'll close. I do want to say a couple things. First, if you did enjoy this, hit the like button because it does help the YouTube algorithm, help other people find us. If you didn't like it, hit the thumbs down. Tell us that it didn't work well and give us some feedback on that. But with that, I'll just say, Asan, thank you so much for joining us. And it's really been a pleasure having you on the show today.
Thank you so much for giving me the opportunity.
So bye, everybody.